So first off, let's have a quick look at our agenda. We are going to have a quick introduction to give you some context of this project that we've been working on. Then we'll go into migration approaches. We'll do a look at identification of fragments that you then could migrate. We'll have a deep dive a bit more into the code, where we look at the Flutter engine and communication between the two different parts of application. Then we'll have a bit more concrete use case from our project, where we had to deal with web views and method handlers, also with C libraries, and we touch a bit on Bluetooth. Finally, we'll do a bit of the full migration, what was missing there, and then hopefully we have some time for questions and answers. So first off, who are we? This is Kevin.
Hello, grüezi. Hello.
And I'm Luke. And we both work for Sulk Engineering, which is a global consulting and engineering service provider with its headquarters in Switzerland. We do, however, have offices across Europe and Asia, and even here some in Germany. So if you're looking for support in your mobile project or potentially look for a new job, please feel free to approach us after the talk. All right, so our customer is Choose Technology. It's also a company based in Switzerland, and they mainly build or develop charging solutions for your electric cars. Their products include a whole range of different chargers, from portable compact ones to fixed installation ones that you might find in your office or in your city. The product that we're going to talk about today is the Choose Booster Free Air. We even brought one with us. It's essentially a compact and portable charging solution with some smart functionality like remote control, remote monitoring, smart load management, and so on. All these things are controlled from one app, that is the J+ Pilot. One note ahead of time, whenever Kevin or I are going to talk about a booster or a charger, we always refer in this talk to this device. We use these words interchangeably during the presentation. So let's look at the J+ Pilot app, at its main functionality. Effectively, you can boil down the functionality in four main functionalities. That would be managing the Choose Booster Free Air, configuring the Smart Choose, which is the load management feature, and then there's two separate parts of the application, which we're not going to talk that much about today, because it's developed by a separate team, and for us, it's essentially just a web view. That would be car telemetry data, which is like a logbook for your car, or charge history as well. And there's Choose Power, which is to buy energy certificates for ecologically produced electricity. All right, when we came into this project, there was already an existing app. It was already live and developed by a previous contractor. However, many of its features had been delayed over months. The code quality was messy, to say the least. It had quite a few bugs as well. And the major thing for the customer was that there were big differences in implementation for features on iOS and Android. You could really see that some features were working on Android but didn't on iOS, or the other way around. And you could also see that this was developed by two separate teams that didn't really talk to each other that much. One other notable thing, especially hurts me as a former DevOps person, is that they didn't use any CI or CD. So but that's besides the point for now. As you can imagine, the previous contractor, Choose Technology, kind of lost trust into them. There was a lack of direct communication, especially with the developers, and little to no transparency regarding feature development. This is kind of where we come into play. As existing Sulke customer, Choose Technology, we were already part of the development of the firmware of the charger itself, so the firmware, the software that runs on the charger. However, back then it was decided that the app would be developed by a separate contractor for whatever reason. So this is a slide where I show you what kind of code we inherited basically from the previous contractor. I'm not necessarily the biggest fan of code visualizations like this, because you might be able to rearrange it a bit better and it could look a bit better, but I think it gives you an idea on what we've been working with and how interwoven this entire system was. All right, Kevin.
Yeah, so as you can see, the application had a lot of problems, but another problem we had is, the code wasn't working, 2 versions. We had to migrate it fast because it wasn't working, it was out in production. How can we do this? And as you know, maybe you know Netscape, it was a browser, and they wanted to refactor their code. It took them 2 years, and in that time, they lost all their market share, and they went bust. So we had to act fast. Another thing is, for example, Microsoft Windows Longhorn. Maybe you've heard of it. Windows wanted to rewrite their entire operating system in 2 years while being backwards compatible. Great idea. No. So they scrapped the project, and even projects like Wine and ReactOS now take like 10 years to get to feature parity. So what do? We need to be fast. How can we do a migration fast? Well, the solution is Flutter, because Flutter only has 1 code base, so you're twice as fast. Well, yes, that's one thing. Further, there were a lot of inconsistencies between Android and iOS. How do we solve these inconsistencies? Well, 1 code base, Flutter, okay. And it enables us to do partial migration, and this is what this talk is about. So whenever you combine native apps with Flutter, there's 2 approaches, and if you're a Flutter developer, you probably know the first approach already. This is the one you use with method handlers, and you can show a native view inside your Flutter project. But now we do it the other way around. So we have 2 native projects, and we want to integrate Flutter to the application. This you can do with the add to app functionality, which you can find in the documentation. So this is the plan of the migration. You have 2 apps which are native, one written in Swift, one in Kotlin, and now we create this weird Frankenstein app. So the green part here is Flutter, and the idea is we eat the app from the inside out with Flutter until it's completely Flutter, and then you get the Flutter app. Okay, so how do we do this? Well, we have web views that we want to migrate, and those are written in iOS and in Swift. iOS and in Kotlin. Swift and in Kotlin. Yes, there we go. And we have, so for example, there was a C library they used in Swift, and there was a Kotlin library they used on the Android side. And, that's not how you should make code if it has to be compatible with hardware. So 1 code base to the rescue. So how do you approach such a migration? Well, first you need to find out failure points. What can go wrong in your application? Yeah, that's obvious, right? Next, you write small prototypes for these failure points. Very important. Let's say you want to migrate web views. It might not work, so you want to create small prototypes first. Next, if there's no CI/CD pipeline, you should set it up. For the old applications first, right? And then you add Flutter to it. You don't want to create the Flutter app first and then do the CI/CD pipeline later, because that takes time and you need to be fast, right? Okay. And then you want to also do testing first. You want to set up Play Store for the old app, and you want to set up Test Flight for the old app. And only then you start with the migration. So you find out fragments in your code that you want to migrate. And so you divide your code into these fragments, and then you prioritize them based on how bad they are, and those are the ones you want to migrate first to rescue the code base. So, Lukas, please rescue the code base.
So let's talk about these fragments. One thing I want to mention ahead of time is that Choose Technology has a strong technical philosophy for web applications. So some of our decisions might have been biased by that, because they really wanted to have as much of their code in web applications. This is mostly because they had web devs themselves, so yeah. We were also told that the highest urgency for the customer was to fix the setup of the Wi-Fi on the charger itself, which kind of meant we had to fix the Bluetooth, which in other words also meant we had to fix the encryption that was used between the charger and the phone. And because the interface to manage this all was buggy, we had to fix that one as well. So you can really see how this cascaded, like, just fix this, please, into a whole bigger change. And it gave us an idea on what we have to migrate first, which would be managing the juice booster, would be these 3 fragments. We then, in a separate step, would also migrate the rest of the application, which would be migrating existing web views, which would be migrating the OAuth functionality, and also the little bit of what was left of the native UI. For this, we all had, for all of these fragments, we had a very similar approach to them. We did rapid prototyping, essentially we wrote small example applications to test out any third-party packages and so on, to test our logic as well. All of these example apps actually ended up as modules in our code, and then we had just one central app that depended on all these modules, and this is kind of how we ended up with a nice separation of concern. All right, now we have quite a bit talked about how this looks theoretically, but how would this look for the user? What was our battle plan? So on the left, you see our old application lobby. On the very top, you see the juice booster, which in our case essentially acts as a button. And as soon as the user clicks this button, he should get into the new Flutter part, so should see a Flutter view. And in our case, because it was a wish by the customer, this would be a web application. So yeah, how do we do this in code? Our story starts with a very simple Flutter module. And then you need to tell Android or iOS, this first will be Android, to run your Flutter code. This is very simple. On Android, you simply add these couple of lines to your settings.gradle file and make sure you depend on that, so you get the dependencies on Flutter. After that, it's basically really simple to start executing Dart code. You simply instantiate a new Flutter engine and define an entry point, which in most cases will be the default one, because that will be main.dart. One thing to mention here, though, is that you really want to start your Flutter engine as soon as possible, because it may take a while to properly start. And you want to avoid any delay for the user when you actually start showing Flutter views. Now, how do we actually, well, we have a Flutter engine running, but we don't show any UI yet. So how do we do this? How do we show Flutter on this button click? This is very simple. In Android, we set the on-click listener, and then we start the Flutter activity. For those who might not know what an activity is on Android, you can imagine your existing Android application running, and then you put on top of it the Flutter view. It's also possible to do this with fragments. So if your application is more based on fragments, you can do this. However, it's a bit more complicated because it involves hooking into the lifecycle of your activity, but it is possible. Then there's just one last thing that stops this before working. You need to add your Flutter activity also in your Android manifest to your other activities, and then this is running for you. Now, Kevin, how does this look on iOS?
Yeah, how many of you have Swift experience? About half. Okay, cool. That's roughly what we thought too. So we just quickly wanted to explain the Swift project. So normally it has an app delegate, a scene delegate, a view controller, and then these storyboards. So actually first, the scene delegate contains a window for your application. Oh, easy, okay. And then the main.storyboard, this is a Flutter UI. This gives you kind of a low-code way to implement UI on Swift. So this is just an example. This was not our application, but also the slide will be available later as a QR code. You can look at the code and implement it for yourself. in case you want to put Flutter into a native Swift project. All right, so we have this button, and if you click on the button, you will call this function, show Flutter demo communication view. And if you set the label, it will then write to that label simply after. Okay, cool. So now we need to integrate the Flutter engine, right? So for this, we recommend you use this class. You can write the class yourself. The class should contain two things, your Flutter engine and the view controller. And then you initialize it just like this in the documentation. Okay, easy. Also, you need to initialize the pod file. So here you need to, inside the pod file, you need to link to your Flutter application that you want to use. And run the post install script. And all the things you normally do inside the pod file for a Flutter project, you now want to do inside this pod file, not inside the pod file for your Flutter application. One important thing that they don't mention in the documentation, you want to add these 3 lines. You want to set the deployment target manually. This will just make it so it works. All right, easy enough. So when you click the button, you start the service. So far, you don't have a window. And now you have a window. So now you just need to set the view controller, and you need to display it somehow. You can either override the root view controller, or you can have a native navigation push, and then you can show the Flutter view like that. Or you can use a slide. You can just add the Flutter view as a slide. Anything you want to do, you can do. Do you see problems with this code? Yeah? I think you got it. So when you click on it, you start the engine. Now you go back, click on it again, start another engine, and so on. So you get a memory leak. So if you ever implement this, obviously you don't want to get the memory leak. You don't want to start the Flutter engine over and over again. But, so, what you would do normally is you would just deinitialize the engine, right? Just set it to null. But unfortunately, no. That's not how you should do it. Don't destroy Flutter. You don't want to hurt Flutter. There's a few reasons. First of all, restarting takes a lot of time for the Flutter engine to start up again. Also, destroy context is very buggy on iOS, just so you know. And even if it would work perfectly, you still don't want to do it because all the Flutter packages you depend on, they normally don't have a deinitialization function. So when you destroy the engine, it will not free the memory for the plugins. So if you keep restarting the engine, you will still create more memory, more memory, more memory. So instead, and then it's much harder to debug when you write the code. So instead, hide Flutter. Just hide the view controller when you don't need it, show it when you need it. And then, if you want to change between views, you use the message handlers, right? So message handlers are a way to communicate with native from Flutter. But we'll get to that. Now, one very nice thing, also if you want to convince stakeholders to use Flutter, if you have a native project, if you run a Flutter engine, you will get this inside your output, both on Kotlin and on Swift, and you will get this link, 127011, local server. And then inside your Dart code in another IDE, Visual Studio, you can then click on attach to Flutter process. You can paste in the URL, and then you can debug your code. But if you destroy the context every time, this won't work. So that's another reason. All right, how do message handlers work?
Now at this point, we have a running Flutter engine and can display Flutter views. However, this isn't really that useful yet, since there's not really a communication yet between your existing application and your Flutter port. So let's talk about how we solve this. The way you do this usually in Flutter is with method channels. And it essentially allows you to communicate between Flutter and your native port. For your integration and migration, this will be your bread and butter. So definitely have a look at them. this communication works bidirectionally. So Flutter is able to call native, but also native is able to call Flutter. Good. Now, Flutter really offers a nice abstraction layer for us here. You can pass messages in between the platforms, or in between Flutter and the native platform, with JSON-like values. And Flutter even helps us with automatic type mapping between the different parts. So for example, a bool in Dart will become a boolean in Kotlin or an NS number in Swift. And this process happens completely automatically, which is really cool. So a bit more concrete in our case, we had, for example, the OAuth functionality, which was still in the native part of the application, which had to be called by Flutter. So we did that, and however, we also migrated some features into Flutter, which were still required by the native platform. So we had effectively bidirectional communication. So let's have a look how we do this. How do we set this up? Again, it's quite easy. You simply instantiate a new method channel object here in Kotlin, give it a unique name, and link it to your Flutter engine. You do this in Kotlin, in Swift, and you do this once more in Flutter. Just always make sure you use the same unique name. Now, at this point, this isn't really that useful yet. You still have to configure the method channels to do actually something. And you do this with method call handlers. And the way this works is really simple. You effectively get a callback function where you match the name of the method to one that is native in your code. So this basically acts as a mapper between your Flutter code and between your native platform. You do this again on Kotlin, but also on Swift. And then the way you invoke a method like this is super simple with invoke method, which is a super normal asynchronous method that you can await. As mentioned, this also works the other way around. So here you have a switch case on the Flutter side, which can then be called by the native platform, again with invoke method. It looks on the native platform a bit different, but essentially works the same way. Good. One caveat I want to mention here. Flutter method channels on their own are not type safe. They only provide you with automatic type mapping, but type safety isn't really a thing there. You can achieve type safety with a tool called Pigeon, which essentially generates some code for you. However, we did not end up choosing Pigeon because for us, we knew this was only a temporary solution until we migrated to the full Flutter version, and so it wasn't really worth the effort for us to set it up. So very quick conclusion on Flutter Engine and method channels. Flutter Engine is the first thing you want to get going to even get anywhere remotely to migrating. Then method channels will be your bread and butter for your integration or migration, and don't fear them. And lastly, definitely define fragments. Think about where your responsibility lies, what do you migrate at which point, and then according to that, define an interface between the Flutter part and the native part.
Yeah, no worries. If you didn't get all the code, there will be a QR code at the end where you can look at all the code and review it. All right, so one of the things we want, so here's a few common pitfalls. One of the things is you might want to migrate a web view. So if you ever want to implement a web view with Flutter, we suggest use a Flutter in-app web view. It's available on Android, iOS, and macOS. And if you also want to target Windows, we recommend using WebView Windows, which uses the Edge browser on the backend, or on the backend at the back of the system. This is our migration step. We now have this Frankenstein app. Just to show you, the web views originally were running the native Safari browser and the native Android browser. Now we just use one code base, but this plugin still targets the same browsers, but we just have one code base. So if we implement anything in a strange way, I can later show you a trick so that the code base always stays the same. But anyways, on iOS we use WK WebView. On macOS as well. Unfortunately, on macOS, the plugin cannot add the web view inside your Flutter application. It will just create a new window or a tabbed window. For us, this was enough. If you need it inside your Flutter application, you can use this web view CEF, which is based on Chrome. All right. So now we want to set up this browser, and we want to make sure it works the same under Android and iOS. All these settings you see here, please use them. This way, the browsers will act pretty much the same way. One thing to note here is if you want to enable the cache, it will not refresh your website if you reload it. Keep that in mind if you want to push updates. And another thing that's important is shared cookies. If you set any cookies on your Android browser, it will also be set inside your app. So that's something you should maybe think about. So, do you want? Probably not. Cool. And then we also had to communicate with the web views, and from Flutter, this works very well with asynchronous functions. Again, the code will be later available. But basically on JavaScript, you use promises, and on Flutter, you use asynchronous functions. This also works in the other way. And for Windows, that also works, but by default, it's synchronous, so you need to make it asynchronous yourself, but that's not so difficult. So, yeah, look at this when you're home. One important tip whenever you do a migration, or one cool trick you can do, you can run your Flutter code on 2 different computers, set the same debug points, and then on one side, run your iOS simulator, and on the other side, run your Android simulator. And that way, you can just run the application. You can click through the debugger on both machines, and if there's anything that's different, you will notice it. So that's a tip for the migration. Another thing, we had a lot of talks about C libraries, so I'm just going to mention a few small tricks you can use. Why do we need C libraries? So this embedded hardware uses a C library to communicate over Bluetooth, and it uses MTLS over Bluetooth. Yeah. Normally, you should set up a TCP connection first, but it works, so that's good. And I'm just going to show a snippet. So this is on the booster, for example, C code. This is how you initialize, C code. Who here knows C? Less than half, okay. All right, so C, pointers, C. But sometimes C has these very crazy functions where you have, this is a standard function, but then as an input, it takes a pointer. And then it has a lot of callbacks in C. So here you have a function that as an input, it's a function that returns an int, and as an input takes a void pointer, unsigned char pointer. That's not right, but that's C. It's always hard to figure out what the function actually does. There's even a website for this, cdecal.org. But yeah, you can use FFIGen to just transform your C library to Dart bindings, but that's not enough. So this part is easy. If you only have C code like this, it's very easy to set up. Need to allocate a pointer. You can call calloc. This is provided by Dart FFI. Okay, so far so good. But now, how do you call this monstrous function here? Let's see. So, first part is easy. First argument, you just need to pass a pointer to this object. Okay, we have it here. We can pass it. Right, easy. Next one. Okay, we need to pass the entropy, but it's a void pointer. But we don't have the void pointer. We have this embedded TLS CTR debug context pointer. Okay. How can we solve this? Oh no, sorry, the entropy pointer. There's a cast function, so we can just cast any pointer to another pointer. Oh, okay, good. Ooh, now we need to get the C string inside Dart. Well, luckily, Dart FFI provides you with a way to create UTF-8 strings in Dart, and then, in a C-compatible way. And the way you can, here you have a string, my custom seed, and then you can call the two native UTF-8 function, cast it, and you're good to go. So, and the only reason this works is because UTF-8 and ASCII have the same representation. So, okay, keep that in mind in case you ever have to do this. But now we get to this crazy function here. And actually, it's even more crazy because we need to take a C function from the library and pass it to this C function. Okay, how do we do this? Well, this C function here, FFIGen, creates this nice bindings, as they would normally, but it also creates a hidden pointer to the function. So if you ever use FFIGen, keep in mind, if you need a pointer to the function, it will also generate it for you. And you can rename it. You can make it from private to public. Okay, now we can use it. Okay. These are a few tricks if you ever have to implement C in Dart. Think about this slide. Okay.
Thank you. I'm glad you're still here. Yeah, that lot of C code. We're going to narrow down Bluetooth quite a bit here because we realized during making the talk we're running out of time. So we only highlight very briefly our experience with Bluetooth that we had. We essentially only use Bluetooth to tell the booster to scan for Wi-Fi's around its area and then to connect one of the Wi-Fi's. For that, we chose Flutter Reactive BLE because it was backed from Philips Hue, and this has been working well mostly for us. We did, however, encounter some platform differences. For example, on Android, the MTU size was calculated a little bit differently. On Android, we had a priority issue where data arrived in the wrong order, and we had also, well, that's not really an issue, but we had a Bluetooth scan rate limit on Android. That is something that you have to take in mind, especially when you design your user interface, that you're only allowed to scan for Wi-Fi devices X amount of times in a minute. Yeah, one thing here we realized during making the talk is that the Flutter Reactive BLE library has not been updated in the last 6 months. So I'll definitely recommend you to check out if this is still an active version or if this is still actively maintained. But for us, it has been working really well, and yeah, we can recommend it. This very shortly are the Bluetooth fixes we had to make in case you ever go back and think about, yeah, Luke said something about Bluetooth issues. This might fix it. And yeah, that's it about Bluetooth.
Yeah, those Bluetooth issues were not really the library's fault. It's like some special Android phone has a different priority for Bluetooth. Okay. But okay, so now we have the Frankenstein app. Now we do the final migration from the Frankenstein app to the Flutter app. So if you listened, you now have a migration step. So you don't need to have 1 year of migration in which you lose all your customers. Hopefully, if you listen to this talk, you have a decent migration. And now, it's running. But now we do the final step. We go from the Frankenstein app to real Flutter app, Flutter only. Again, I want to reiterate, if you added these fragments one by one, you will have separate Flutter modules for each of them. Okay? And luckily, Dart is strongly typed. So refactoring becomes a lot easier. So for example, this is an example we had. We had this OAuth, and we had to get the OAuth token from the native side. One time on Android, one time on iOS. Okay, but now we had to do it natively. So, we use this code in like 30 different locations. How do you do this? Well, you just change the type because it's strongly typed. You just change the type of the function, of the class, just the type. Make sure you specify everything you need. And then because it's strongly typed, it's a skill, you get 38 problems, but that's no problem. You just go through all the problem, and if it type checks, ship it. Right? This is not something you can do in a language like Python, for example. If you want to refactor a large amount of code, there's type extension. That shouldn't be so rude. But yeah. And that's it. I hope you enjoyed our talk. If you have any questions, please come up. Yeah, so again, this is the company we work for, and this is the charger. If you have 2 electric vehicles and the fuse, when you charge both of them, gets shorted in your home, I think this is the only smart charger that can solve this problem at the moment on the market. So. Thank you.